All right, you guys, in this section, we're going to continue talking about complex numbers, and then we're going to get into operations dealing with complex numbers. Okay, so before we begin, let's define what a complex number is. So a complex number is a number which is in standard form of a plus bi, where a and b are real numbers and I is the imaginary unit. Okay, so a complex number is any number that takes this form, a plus bi. Okay, where a is its real part, bi is its imaginary part. So all of these are examples. So 2 plus 3i, or 3 over 4 minus 1/4 I, those are examples of numbers written in complex form. Okay. Now, the cool thing is, all of the numbers that you've encountered so far, even though they didn't look like it, can be written in their complex form. Okay. So earlier in this section, we took some time to talk about imaginary numbers. All right. We talked about the imaginary unit, which is I. All right. And so we've got a couple different types of numbers. So we have a complex number, which is how all of our numbers could be written. We have imaginary numbers. We have purely imaginary numbers. And then we have real numbers. Okay. So an imaginary number, okay, is any number that has a real part as well as an imaginary part. So a plus bi, so a and b would be real numbers. So like 2 plus 5i, okay. You have purely imaginary numbers which have no real part. So their real part is 0. So that would be a number like 0 plus 5i, which we typically don't write the 0 in front. We would just write it as 5i. Okay, but in complex form, you would include it. And then we have our real numbers, which are the numbers you guys are most familiar with. So like if I had the number 5, okay, typically we don't write 5 in its complex form, but if we wanted to, it would be 5 plus 0i, because it has no imaginary part, so it would be 0. Okay, so any number that we have can be written in its complex form. Complex form just means it has a real part and an imaginary part. Okay. So now that we have the definition of what a complex number is, let's get into some operations. Okay. So the first thing we're going to do, we're going to learn how to add and subtract complex numbers. So to add or subtract complex numbers, we're simply going to add or subtract their real parts and then add or subtract their imaginary parts. So if you want to think about it, it's like combining like terms. Okay, so our directions say to add or subtract the complex numbers and then write the final answer in standard form. Okay, so standard form is a plus bi. Okay, so let's look at a. So for a, we have 3 plus 4i plus negative 1 plus 5i. Okay, so when we're doing this, we're going to combine the real parts of our number. So the real part of the first number is 3. The real part of the second number is negative 1. So 3 minus 1 is 2. Then we're going to look at their imaginary parts. We have 4i plus 5i. So 4 plus 5 is 9. 9i. That would be our answer for the first one. Okay. All right, let's look at b. So b, if we're combining the real parts with the real parts and the imaginary parts with the imaginary parts, the first number in b, if you needed to see it, it would be like plus 0. This number doesn't have a real part, so it's understood to be 0. So we would say 0 minus 3. That would be negative 3. And then we would have 7i minus I. So we would combine their imaginary parts, which would be 6i. Okay. Let's look at c. So for c, if we combine the real parts, okay, we have 5 and negative 4, but we're subtracting, so it's going to change this sign to positive. So we have 5 plus 4, which is 9, okay, and then we're going to combine the imaginary parts. So in this first number, it's 9i. The second number doesn't have an imaginary part, so it's understood to be 0i. So if we combine 9i and 0i, that's going to be 9i. Okay, and those are our answers. So you have to remember that you're going to combine like terms with like terms, reals with reals, imaginaries with imaginaries. Okay, so that's adding and subtracting. Let's move on to our next operation. Our next operation for complex numbers that we're going to do is multiply. Okay, so the rule for multiplication says to multiply complex numbers, we use the same rules that we normally use when multiplying non-complex numbers. We use the power rule, distributive property, and FOIL method. Okay, so they want us to multiply the complex numbers and then to write our final answer in standard form. So remember, your standard form is A plus BI. Okay, so let's do the first one. So we have purely imaginary numbers for A. We're going to multiply their coefficients together and multiply the i's together. So 5 times 2 is 10, and I times I is I squared. Okay. We know that I squared is equal to negative 1, and 10 times negative 1 is negative 10. Okay. All right, let's look at B. So B wants us to do 7i times 1 plus 5i. So we're going to distribute, okay, the 7i to both of those terms in the binomial that comes behind it. So we're going to have 7i times 1, which is 7i. And then we're going to have 7i times 5i. So we're going to multiply 5 times 7, which is 35. And I times I is I squared. Okay. We know that I squared equals 1. So I'm going to write this out. Okay. And 35 times negative 1 is negative 35. Okay. Now, because they want this answer in standard form, it means that you have to have A plus BI. So the real part of this number needs to come in the front. So I'm just going to change positions. So this is 35 plus 7i. Okay. All right, let's look at C. So C, we have 2 terms times 2 terms is what it looks like. So anytime we have a situation like that, we're going to use FOIL. Remember, FOIL stands for first, outside, inside, last. So we're going to multiply our first terms together. So 2 times 2 is 4. We're going to do our outsides. 2 times negative 9i is negative 18i. We're going to multiply the insides. 2 times 9i is 18i. And 9i times negative 9i, that's negative 81i squared. Okay, so we're going to go through and simplify. So I can look at my 2 middle terms and notice that they're the same, but they're opposite in sign. So they're going to cancel when we combine like terms. So it's going to give me 4 minus 81 times negative 1, because remember I squared becomes negative 1, which is going to give me 4 plus 81, because a negative times a negative is positive. And then when I add them together, it's going to give me 85. Okay. All right. The other thing, if you guys notice that the binomials in C, those were conjugates. So remember, conjugates have the same front and back term, but one has a plus in between the two and one has a minus. So remember, anytime you're multiplying conjugates together, the middle terms, the O and the I of FOIL, are going to cancel. So just in case you forgot, C is an example of conjugates. Okay. All right, let's look at D. So D, we're going to FOIL again. 4 times 1 is 4. 4 times I is 4i. Negative 5i times 1 is negative 5i. And negative 5i times 1 is negative 5i squared. All right, if we simplify and combine like terms, we're going to have 4 minus I minus 5 times negative 1, because the I squared becomes negative 1. That's going to give me 4 minus I plus 5, because the negative 5 times the negative 1 is positive 5. And then we're going to combine our real parts. So 4 plus 5 is 9. 9 minus I. Okay? So be careful when you're doing these, that you're distributing the things that need to be distributed. Remember, anytime you have I squared, that becomes negative 1. So be careful with your order of operations and how you simplify. Okay? All right, let's look at our last operation. So we've added and subtracted and we've multiplied numbers in complex numbers. So now we're going to divide. Okay, so the directions for division say to divide complex numbers, multiply both the numerator and the denominator by the conjugate of the complex number in the denominator. So we're going to be rationalizing the denominator, okay? And it says the product of two complex conjugates is a real number. So that's going to be important. So just like when we have something like 5 over the square root of 3, and we can't leave the square root in the bottom, the same principle is going to apply to imaginary numbers. So anytime you have an imaginary number in your denominator, you're going to need to rationalize, okay? So that same concept that we dealt with when we had radicals in the bottom applies here, okay? So our directions say to divide the complex numbers and write your final answer in standard form. So remember, our standard form is A plus BI, so don't forget. All right, let's look at A. So A says 2 minus I over 4 plus I, okay? So originally, there's nothing that can simplify in that problem, but we can't leave it the way that it is because there's an I in the denominator, okay? So we're going to need to rationalize this. So since there's two terms, the 4 plus the I in the denominator, we're going to rationalize by multiplying by the conjugate, which would be 4 minus I over 4 minus I. Okay, so remember when you're multiplying by the conjugate, it's going to have the same front term as the denominator, same back term as the denominator. But if you start with a plus, it's a minus. If you were to start with a minus, the conjugate would have a plus. Okay. All right, we're going to have to FOIL our numerator and our denominator. So 2 times 4 is 8. 2 times negative I is negative 2I. That's negative 4I. And negative I times negative I, that's positive I squared. All right, in the bottom, we're going to FOIL. So that's going to give me 4 times 4 is 16, minus 4I, plus 4I, minus I squared. We're going to simplify. So in the numerator, we have 8 minus 6I plus negative 1. In the denominator, the 4 i's are going to cancel. That's going to give you 16 minus negative 1. All right, so let's keep simplifying. In the numerator, we're going to have 8 minus 1, which is 7 minus 6i. And then in the denominator, we're going to have 16. A negative times a negative is positive. So 16 plus 1 is 17, okay? Now, we can leave it like this, okay, the way that it is, like as a single fraction. But if, for example, you are prompted to tell them what the real and the imaginary parts are, okay? So if you are asked to actually split the number apart, you will need to write 7 over 17 minus 6 over 17i, okay? So be careful how they want the answer, okay? If they want it split apart, the one in blue is the one you're going to be looking for, okay? All right, let's try B. So B, they have the same thing. We're dividing, okay? There's nothing that simplifies off the bat, but we can't leave that I in the denominator. So we're going to have to multiply by rationalizing. And we're going to multiply by the conjugate, which would be 5 plus 3i. Okay. We are going to FOIL both the numerator and the denominator. So 1 times 5 is 5, plus 3i, plus 10i, plus 6i squared. And the denominator should be, once we FOIL it, 25 plus 15i minus 15i minus 9i squared. Let's choose a simple. Alright, if we simplify the numerator, it's going to be 5 plus 13i plus 6 times negative 1. And the denominator is going to be 25. The middle terms are going to cancel. Minus 9 times negative 1. Alright, let's keep simplifying. So we have 5 plus 13i minus 6 in the numerator, And we have 25 plus 9 in the denominator, which is going to give me negative 1 plus 13i over 34. Okay. So once again, if they ask you to split those up into their negative and their positive parts, okay, you're just going to split the fraction. So that's going to give you negative 1 over 34 plus 13 over 34i. Okay. So just be careful. All right. Let's work on the last one. So for this one, we have 10 over 9i. Okay. So once again, the way that it's written, we can't simplify any farther, but we can't leave it the way that it is because of that I that's in the denominator. So we're going to rationalize by multiplying by the conjugate. So since this is a positive 9i there, I'm going to rationalize it by multiplying by negative 9i. Okay. And I'm going to multiply straight across. I'm going to multiply the numerators together and the denominators. That's going to give me negative 90i over negative 81i squared. When I do that, a negative over a negative is positive, and I squared is negative 1. That gives me 90i over negative 81. Okay. And then both 90 and 81 are divisible by 9. So it's going to give me 10i over negative 9. Okay. So in this section, we learn how to add, subtract, multiply, and divide numbers that are all written in complex form. Okay. So I hope that this is helpful.